Hi, this video lets you collect data to investigate how the force on a conductor varies with current using a top pan balance. You can test the theory that the force on a conductor in a perpendicular magnetic field is proportional to the current. By using the formula F equals BIl, you will be able to calculate the magnetic field strength, the flux density, of the magnet that we are using. Our first task is to make a uniform magnetic field. We will use this iron cradle and these strong ceramic magnets. They're quite brittle, try not to chip them. And we need to make sure that the faces opposite each other are opposite poles. Let's put it on the electronic top pan balance. We're actually not interested in the weight of the magnet, which gives this first reading of mass, so we press the tare button. We want to measure the apparent change in mass as it pushes down or is lifted up by other forces. With this additional magnet, I can pull up on the balance or turn it over and push down. When I pull the balance upwards, there is a Newton's third law of force pulling my hand down, and my hand is pushed up when the balance registers an apparent increase in mass. Good. Now let's build the circuit. We're using a brass tube held by wooden blocks. Now notice that the brass tube has no magnetic effect itself. Connect to a DC power supply and a digital multimeter set to 10 amps DC mode. Complete the circuit and we're ready to go. You can pause the video during the following experimental run to take readings of current and apparent mass change. We will slowly increase the current up to the maximum of the power supply, about 5 amps. The magnets are being pushed down, so the conductor is being lifted. Okay, that's the maximum. So now we'll extend the range by reversing the current. The magnet assembly is now lifted up, so the force on the conductor is downwards. To calculate the force in newtons, take the apparent mass change in kilograms and multiply by G, 9.81. That's the maximum current we can get with this power supply. So the last job is to measure the length of the conductor in the magnetic field.